once again, this is a QR code for Google Form, and there is just one question. How many lines are there in F# compiler, in the source code of F# compiler? Try to guess. The closest number will win a ticket to the Update Conference 2019 taking place on the 14th and 15th of November. It's here in Prague, yeah. So at the end of the talk, we will find the winner. Before that conference, you should be able to visit our workshop. It will be about Safe Stack. Safe is a set of technologies allowing full stack development for web applications entirely in F#. We will go through all the technologies and try to build a real application entirely in F#. So yeah, let's get back to the language. Are there any people who know already F#? Can you raise your hands? Okay. Okay. So I hope you find this interesting then. Why F#? Why functional programming actually? Functional programming is a special paradigm which is not like very common, very popular object-oriented paradigm. But the thing is, you don't have to use it entirely in the whole application. You can mix those techniques, you can mix the paradigms and become better. So there is an opinion that you will be a much better developer if you try. Just give it a try. Some functional language doesn't mean it must be F#. Any Haskell, whatever, Clojure. Just try it, and you will become much better developer than you are at the moment. Also, F# is such an expressive language, which you can actually try to write as a kind of a pseudocode, really uncommented, tweak a bit, and then build, and it should work. Actually, there is an opinion again that if F# application compiles, then it actually works. Which we can say about any statically typed language, but yeah, sometimes exactly Haskell and F# are mentioned in this context. So let's quickly go through what F# is actually. So it's a multi-paradigm language. It doesn't have to be functional only. It supports object-oriented programming, even though it's not idiomatic. So that's why it's functional first language, and you do it declaratively with combining, composing only functions and trying to avoid all those object-oriented design patterns, any inheritance, I don't know, classes, interfaces. But you have all that. Everything is there in F#, so you can do it. It is statically and strongly typed, so that means if, again, it compiles, then it probably works. There are few possible runtime exceptions, but it's not like JavaScript when everything is dynamic and you never know what happens in the runtime. Also, a good benefit is that it has type inference, which means you don't have to specify the types all the time. So it will just try to find, the compiler will try to find the type from the context. But sometimes it needs help. Another great advantage of F# is that it's open source. It's not kind of Microsoft enterprise thing as C# is. So Don Syme is the creator of F#. He's also the creator of generics in C#. He wants that language to be, the F# language, to be open source all the time. So there was even an idea to rewrite the compiler using Roslyn or something like that, but he refused that because he wants to be kind of distant from that enterprise-ish way of doing things. It must be driven by the community. F# is also cross-platform, so you can run it on any operating system, Windows, Linux, Mac OS, even Android, which is also Linux, I believe. So it's cross-platform and very performant, thanks to .NET Core, which is, and you can also use Mono, but nowadays I don't think you need Mono. And later on there will be .NET 5, combination of all those .NETs and Monos and .NET Core. So yeah, let's wait for it. Another great benefit of F# is that it can be compiled into JavaScript. So JavaScript acts as another runtime of this language. It is thanks to Fable. Fable is a compiler, or better say transpiler, to abstract syntax tree, Babel abstract syntax tree. And then Babel takes care of compiling that into a real JavaScript, which is supported by by all browsers, or at least almost all browsers. We will have a look at Fable later on. It can be also as a scripting language, so you can write scripts, and there is Fake as a great DSL for building, deploying, combining all those package managers, testing, and so on. So your application can be entirely written in F#, including scripting. And there is also REPL, read, eval, print loop, which can be used while developing. You just send your lines of code into REPL, test them immediately, see the result. It also keeps the state. So, and you don't have to compile the whole application to run some pieces of F# code. And the last but not the least, F# has an awesome community, like really amazing. It's so supportive, so warm. There's even F# mentorship program, so you can find a mentor, and he or she will help you to understand, to go deeper with F#, and it's for free. Yeah, so I would highly recommend to at least look into F#, and you will get a lot of support just instantly. Where to use F#? As I already mentioned, and we will cover this topic more deeply, like really deep, at our workshop, Safe Stack. Safe is an abbreviation of Saturn, Azure, Fable, and Elmish. These are the recommended set of technologies for full stack development of web applications in F#. So it doesn't mean that you have to use all of them, or it's not strict. It's just the recommended set. And Saturn is a web framework which is built on top of Giraffe. That one is built on top of ASP.NET Core. So basically it's the same technique, but trying to make it more functional or declarative. Azure can be replaced, I don't know, with AWS or Google Cloud, and that's the same thing. Basically any provider would work. Fable, yeah, this is the only thing which kind of cannot be replaced, but there is also Web Sharper, which also allows to transpile F# to JavaScript, but it's not that flexible as Fable. And Elmish is the way to store the state of front-end application. It's similar to Redux, but it's a bit different. It's actually borrowed from Elm language. Elm is the purely functional language inspired by Haskell, but it compiles to JavaScript. And it also brings the model view update architecture. It's not something super new or something unique. Basically, Redux is pretty much the same thing, a bit different. But there is a great implementation in F#, which is the most common for front-end development in this language. Functional language, F# as a functional language suits very perfectly to serverless, to functions as a services. Which language would you use to write functions? I would prefer functional. So yeah, again, any provider, Azure Functions, AWS Functions, OpenFaaS, I don't know, anything. You can even do mobile development thanks to Xamarin. I forgot to mention WPF there because there is an implementation for Elmish architecture, for model view update architecture, for Xamarin and for WPF. And you can use React Native, which is basically, again, transpilation to JavaScript. I believe any JavaScript cross-platform mobile framework would work here. I don't know, Ionic or Iconic, I don't remember any names, but it's, again, compilation to JavaScript and then the usage. F# has great tooling comparing to other functional languages. If we consider, I don't know, Haskell Clojure, they don't have that great tooling. Maybe only Scala could compete because it's used by JetBrains, and the JetBrains writer is personally my preferable IDE for F# development, but you can go with some free solutions like Visual Studio Code with Ionode extension. that also works pretty well. We'll probably use that one at our workshop since it's free and open source, by the way. Or you can use Vim F# plugin. This is for real coders. Vim, but there are a lot of tooling and they're great. Let's go through the basic syntax this time. So since F# is immutable, it has only values. There is no such thing as variable, actually. Well, it could be, but by default, it's just a value. And it's immutable. If it's an age equals 30, then it's 30. So basically, with let keyword, let is a binding. It's a keyword for binding some value to some name. So we bind the name age to the value 30. And compiler infers the type of it. It becomes integer. We can specify the type explicitly if we want. Also, we can replace, like reassign, rebind the same name to completely different type. As you can see, it's integer. It used to be integer, and now it's string. And we are reusing the previous value of that name, like assigned to that name. So this is the immutability. Basically, it's not changing anything. It's always a new value. And also, I must mention that everything is an expression in F#, so everything should return something. And if your function, let's say, doesn't return anything, actually it returns, or it must return unit type. It's similar to void in C#, but not exactly the same. So you must return it, and void and unit can be written with just two parentheses, a pair of parentheses. Of course, functions are the core elements of F#. So it's the same thing to declare a function as to declare a value, to assign a value. So there is a let binding, and we bind a function to name add, and it expects two arguments, and then it adds them up and returns. This will be the return value. There is no return keyword for a function. Doesn't have to be, because it's an expression. It must be something at the end, and F# doesn't use curly braces, so it's only indentation. But if you just think about it more, we don't need it. It might be kind of frightening because we're used to the C syntax, so like the language to the C syntax with curly brackets. But actually, when you recognize the scope, you look at the indentation. If you remove the indentation and keep only curly brackets, you will be lost. So just think about it, and indentation is more than enough. All functions are carried out of box. So what is carrying is it's a way of passing just part of the arguments. So in this case, I'm passing just 10 as a one argument, and I get a function back, not the value, but it's a function which expects the second argument. And no matter how many arguments I have, I can pass just some of them. So all functions are carried, so you can use partial application and pass functions around. As you can see, there is a function exec, which this is a way of passing x and y. It's actually one value. It's tuple, so you must pass them both at the same time. You cannot use partial application here. So it's one value, and the second value is a function, which expects, which is a function of two arguments and returns just one thing. We can even define our own operators, which some crazy operators, as you can see. But actually, for this particular function, there is already a built-in operator which just decomposes the tuple and passes to the function the values. So you can see minus passed as a function. Everything is an expression again. Once again, everything is an expression. Even the operator is an expression, it can be passed as a function. So it expects two arguments. Then why not? Why don't we pass it as a function? You can define types. You can explicitly say that I expect integer, or we can use generics here. It's pretty much the same as in other languages, just a bit different syntax. Mainly the value and only then the type, not another way around. You can declare a type which will be a signature of your function, like add function expects integer, another integer, and returns an integer. And then you can define your function with lambda functions. And everything is statically typed, and you see the type like while typing, while writing your code, and when you're compiling, everything is statically and strongly typed. The data in F# can be described in several ways, and one of them is the record type, so-called product type. It's similar to, I don't know, some DTO, if you're familiar with this term, but they are immutable. They are immutable and they are non-nullable. They cannot be undefined. You must provide all the fields at the moment of creation, like you can see. The user has first name, last name, and the age. And if you try to change the age, that won't work. Actually, that will just give you the result false, because here the equal sign will be treated as a comparison, and the comparison will give you false because user.age doesn't equal 31 yet. You can use mutable thing, to create a new object of that type. You can reuse the existing one with changing just one or multiple fields of that. And if you really need to mutate something, there is a mutable keyword which allows you to do that, but usually you don't do that in functional programming and declarative programming. Everything is immutable. If we go a bit deeper, this a record type is by default it's a class. It's a reference type, so it means it's stored in the heap, but compared by value. So there are equality members overridden just to make this comparison by values, and you can override even that and compare them, I don't know, just by one ID or by reference if you really need that. But we won't cover that in this talk. Also, there are anonymous records, of course, so you don't have to specify all the types all the time, but this is pretty fresh thing. I mean, it's quite new. F# 4.5 or 4.6 only introduced that construction, but yeah, it's even more powerful than I expected, because you can expand the types based on the previous type. So you can see data has two arguments, x and y, but the expanded data will have 3 fields just based on the previous one. And there will be another type, of course, but with more fields. And this also can be done based on the named type, like R here. This is basically all about records. So let's get closer to algebraic data system, which is the core, one kind of the most powerful things in F#. So there is such thing as discriminated union, which is also known as some type, and it can represent just one of possible values. So if it's a card type, then it could be either Visa or MasterCard. That's it. There is no way to use another value, or it's kind of enum, but it can have additional data. Like here you can see in payment method, it's either a cash with no additional data, with no extra data, it's a check with a check number, that must be there, or a card with card type and the card number. So yeah, we keep everything in one, and while creating any of those payment methods, you can see check or cash or card payment methods, they will all be of the same type, which is the payment method. So then you can match them against some values, which we will see a bit later. So thanks to this discriminated unions especially, F# is really awesome for DDD, and not only thanks to discriminated union, but also thanks to naming. This is a perfectly valid name of a function. And you can actually write really great tests with meaningful names without underscores or camel casing here. So, but the part of that, the type system is so cool that you can write objects, you can describe them not in technical terms like integer or float, but it's something more meaningful. Let's say we sell gadgets, and a gadget might be a phone or a tablet, let's say, just limited to just two things at the moment. If we talk to a business person, for a business person, that person knows that gadget must have a code, which is some gadget code, which is either phone code or tablet code, and there are differences between them. So the phone code starts from T and has only 5 characters, and the tablet code is some integer number in some range, right? So if we describe our model, our domain this way, we can actually show it to the business person and say, yeah, do we describe it correctly? So a gadget code, it's either a phone code or a tablet code, and then it has a gadget name. Look, there is no string or anything like any keyword specific for a language. It's just gadget name, and there is a weight in grams and screen size in inches. But from my point of view, this is really clear and can be confirmed, agreed with the business people much easier than when you say, yeah, the name is a string and the weight is float or integer. What is float or integer for a business person? Well, yeah, some of those people know, but not all of them, definitely. I had strange discussions with those people sometimes. But yeah, F# allows you to name the things as they are. And that could happen thanks to also discriminated union and single case union. So you can see gadget name of string is actually a discriminated union which can have only one case, and it must provide an additional extra data string. That's it. Or if it's a tablet code, it must have some integer inside, but it is called tablet code. And then later on, in your business logic, where you actually have your domain logic, you operate with these names, not with integers or strings, which makes it more kind of cleaner. There was a restriction on phone code, and let's have a look how we can implement that. So it's a phone code, it's a type, and I'm declaring it as a private, having a private kind of constructor, phone code of string, which we won't be able to use. You can see that it won't compile in the second line of code. And deconstruction of that value won't also work in different modules. We can create a module, phone code, with just 2 functions, create, which will have some validation. So the string must not be null, it must start from T, and the length of the string should be 5. And then we return some phone codes with that string inside, or none. Option type is the way of declaring missing value in F#, because in F# there is no null by default. Yeah, you can see it for strings, but for other types there is no null. And we try to declare everything explicitly. So if there might be missing value, we say it explicitly. Then we return an option type, and it's generic, so we can return basically any type wrapped. It could be named maybe monad, if you heard about that. And yeah, and the value just returns the code with deconstruction, but only if that module and that type are in one namespace or in one module, parent module. Thanks to discriminated union and immutability, we can pattern match all the values. So here, this code might look a bit more complicated, but it's actually very neat, I would say, because there could be a direction of a wind that's simple. It's kind of enum again. And the weather could be either cold with some temperature. Here we see the units of measure, one more built-in feature in F#. So this is the unit of measure, and you won't be able to pass a regular float or any, I don't know, gram into temperature because it expects the Celsius degrees. So the weather could be cold with the temperature, sunny, wet, or windy with the direction of wind and the speed of wind. The next construction is active pattern, which sometimes looks really complicated, but actually it's a way of naming your range of values with some name. So let's say when the speed is higher than 10 meters per second, it's really high. And if it's just more than 5 meters per second, then it's medium. Yeah, there is a typo. That dot should be after 5, but sorry about that. And yeah, in other cases, it's low. And then you will be able to pattern match against these values. So you can see here, windy, north, and high. So if the match weather with windy, with north direction of wind speed, and the high speed, and you can see we don't write here like when wind speed is more than something, we just say it's high. And it will be matched against those conditions, and you will be able to use high speed northerly wind. So basically, even this construction, pattern matching, from my point of view, can be read as plain English, almost plain English. Match weather with sunny, nice weather. Super simple. Match weather with cold or wet, miserable weather. And match weather with windy south, no matter which speed it is, it's blowing southwards. So that underscore is discard sign, so it allows any value, and it can be used for just part of the value, like in this tuple, or the whole tuple at the end. A great thing about pattern matching is that it's so-called exhaustive matching. So if you don't provide some case, so your value cannot be matched against at least one case, then you will get a warning. Unfortunately, not error, but you can treat warnings as errors. So basically, you will always know if you forgot something, if you any kind of, well, it might not tell you what exactly you forgot, but at least it will show you that you're missing some scenario. There are several collections as usual in F#, so this is how we define them. You might notice that, we don't use semicolons in F# almost anywhere, but when you want to put values on the same line, you must use them. So the first line shows how we create a list. It can also be created with an iteration from 1 to 10, for example, or another number, or a value named somehow. With those vertical lines, you can create arrays, and lists can also be matched against, let's say, an empty list, a list with the first value equal to 1, or it can match to head or tail. Head will be the first element, and the tail is the rest of your list, and that will allow recursive iteration if you need that. And discard sign, of course. By the way, if we put head and tail case to the first place, it might fail at runtime because there might be no value at all. That might be an empty list. So an attempt to access head will fail. But if we put it lower after the empty one, then it perfectly works. Let's talk about composition of functions. We compose functions in functional programming. It is our key element. So let's compose them. And that's super simple. If we have a function which expects an integer and returns a float, and then another function which expects a float and returns a string, which we can just combine them together and get a function which expects integer and returns a string. It's pretty simple, and then we can reuse it, and yeah, that's another function, even though you don't see any arguments in the declaration. Another way of combining or composing function is a pipeline. So with a pipe operator, we actually pass the value of the left side to the right side, and then further, like the result of that computation will be sent to the next right side, and the next, and the next, and the next, until the end. And those evaluations can be lazy. And so if you iterate over some collection, it won't happen until you materialize it. Like, let's say we have sequence, which is the same as IEnumerable in the C#, until you say something like list of sequence, it won't be materialized, so it won't be calculated. Computation expressions, yes. That's a strange thing. Might look strange in the beginning, but it's actually super powerful. It's a syntax sugar for combining your computations, and you can write your own. There are some built in. For example, a sec computation expression allows you to yield more and yield the values of that sequence, but the elements, and yield with exclamation mark allows you to iterate over some sequence and yield all those values as well. But an interesting thing comes when you have something like this. This is a syntactic sugar for two optional values. So we have option 1, it has value sum 1, and option 2, sum 2. And if we want to sum them up, we need to take one value and the second value, but both of them can be none, actually. So in this case, when we go through that optional computation expression, if the first value will be none, the whole result of that computation will be none, and nothing else will be executed. If the second value is none, we will have the same thing. So this is a syntactic sugar for this, which doesn't look anyhow convincing for me. So actually we bind. So bind is a function which takes the value. So if the option 1 is sum, that function will be executed, and it must return another option. So we return another bind, and then at the end, sum value 1 plus value 2. Much simpler with computation expression optional. So optional is not a built-in computation expression, so it was written by someone and it's open source, you can use it, and it has just, I don't know, 10 lines of code, a pretty simple thing, but it just declares the bindings. Also, it doesn't have to be only known keywords like let, return, yield, or match, whatever. You can write your own custom operations, and this is what Saturn is utilizing here. So this is a declarative way of defining a controller and an application with Saturn. So basically what you do is just say that use router, some top router, whatever, the URL of the application will be this one, and it's very clear. We will go through Saturn web framework in our workshop. It's really powerful. It's inspired by Phoenix, and a web framework written in Elixir. But yeah, in F# it can look pretty much the same, quite declarative. So now you know all those small pieces of F#. And you know what it contains. And let's look at some interesting technique, which was, as far as I remember, it was introduced by Scott Floshin, so-called railway-oriented programming. There is an example. So we have some imperative code, which gets a request, validates it, puts into the database, sends an email, and yeah, returns something. What could possibly go wrong here, right? So this is a way of implementing it without handling the errors, basically. And this is the way of functional flow, the same thing without handling any error. But here we just compose the functions together and execute that. Let's see how it would look like with error handling in imperative programming. So what if the validation of request fails? What if the request is invalid? So we need to check if it's validated. If it's not validated, then let's return request is not valid. Something like that. That, of course, may be much more complicated, but for simplicity, let's use this way. Also, if you try to update something in the database, the entity could be like missing there. You might not find it. You need to check it. And also when you update, something could go wrong in a database or it might be inaccessible. So we would rather wrap it into try catch. And of course, when we send an email, it also might fail, but we might not care that much, at least just log it. And it gives us another condition, another if condition with some log error. How many lines of code did we add? I think quite a lot. I didn't count, but it looks much like messy, let's say. Let's have a look how it would be in functional way. So this is without error handling, and this is with error handling. And probably you don't trust me. Yeah, don't believe me, of course, but that's okay. Let's have a look at result type. So result type is similar to option type, but it not only returns some value and none if there is no value, but it can return some value for OK, for successful result, or some error with some value for failure. This is actually gives us kind of from one track we go to two tracks. Basically, that's how it would look like. A validation function could check for name, email, and in some cases return an error. And if everything is okay, it returns the same input as it was. So this function would switch our execution from one track with one request to two possible outputs, either success or failure. And that looks like a railway track, the switch. That's interesting, but how would we deal with it? How we can compose them? So what we need to do actually is to, on success, we continue on the success path, and if it fails, we just bypass everything and go on the failure track and don't check anything, don't do anything else on the success path. So that's how it should look like, probably. Yeah, but we have a problem. Yeah, and in the end, like this, like really railway track. There is a problem, because these are two tracks. There are two tracks, but our functions are actually one track. They all expect only one thing, one track, basically. So it's just one input with some value, not the result, which can be either success or failure, okay, or error. We could, in every function, we could check if it's success, then do that. If it's error, then do another thing. But that's not what we want. The composition is of one-way tracks is simple. That's we compose them as they are. If there are two tracks to two tracks, that's also easy to compose. It doesn't matter, and that's it. But when we have all functions expecting just one track and outputting two tracks, that's impossible. That won't work. There is no way to compose because the types don't fit, don't suit each other. So we need some adapter. We need an adapter block, which is pretty simple to write, actually. There is a bind function. Bind function expects a switch function, which needs to be applied as the next one. And it expects the two-track input. And then matches two-track with okay, then apply the second function, the next function. If it's error, just return the same error, and that's it. So in the next place, it will be the same check, but yeah, and this is the type, the signature of that function. So it's it expects a function and the result, and returns another result with a different OK, if you can see. So the A and the B don't match, so the OK type will be different. Might be different, doesn't have to. So if we consider our validation function as a set of other functions, like check for name not blank, name must not exceed 50 characters, and email is not blank also, and all of them have the same signature, just one input and the result, we can combine them with bind function. It's pretty simple. And then each function, like bind expects 2 arguments. We pass only 1, so we have a function as a result. And that function has already another type, which expects a result and returns the result. 2 tracks to 2 tracks. Super simple, so we can compose them. Composition works here perfectly. This is our final function, and it has the same type, 2 tracks to 2 tracks. Super simple to combine them. There is also an operator, very common one for binding. It just allows us to simplify this, to not write bind and not place those composition signs, only just one operator here. Super simple, and that's it. Basically, we can combine as many functions as we want, making them 1 to 2 tracks, just 2 tracks to 2 tracks. That's simple. What we don't cover here, and that's just an overview and a pretty quick one. You can ask questions later on if you want, because we don't cover many things here, like single track functions. What if a function is 1 track to 1 track? It's super simple. We just make it 2 track by adding OK to the result all the time. That's like really the simplest way. There could be function throwing exceptions, they can be wrapped, and yeah, parallel tracks. There are a lot more topics to cover. I highly recommend Scott Floshen's talk about railway-oriented programming and his website. I will show a link later. But we need to cover asynchronous programming before we get further. Asynchronous programming in F# can utilize basically all the things from .NET, all those threads, tasks, async results, and background workers. But that's not what you usually do in F#. In F# we have another way of doing things. It's async. Async is a type which represents some computation which must be done asynchronously. And also there is a sync module which has those helper functions to start, stop, and combine those. And async computation expression. You could see that computation expression allowed us to combine things pretty simply. So this is another way. This is another usage of computation expression, and we'll have a look here. Yeah. So we have an asynchronous function which reads all bytes from some file. You can see async.await task. This is the way of integration with C# tasks. It converts, basically it starts the task and awaits it in async F# type. And so that function just prints the name of that file and the total amount of bytes. And we must run that function synchronously. So there is the key difference between F# asynchronous programming and C# programming, asynchronous programming. So every async computation must be started explicitly. This actually gives us more flexibility and control on combining and sequencing these computation expressions. For example, like this. So we get total bytes of a file, and it returns that amount, the length of bytes array, and we then sum them up. So what we see here is that array of paths, some array of file paths, is mapped to asyncs, but when they are, but when we have an array of async computations, they are not started. Nothing is happening. We send them to async parallel and run the whole thing synchronously, and that parallelizes that array of asyncs, runs it in parallel, and returns an array of integers, which we can just sum, and that's super simple. So this allows us to combine and compose computation async expressions very simply. But the most important thing here is that it's not an abstraction over threads. It's async computation might be executed on another thread. Doesn't have to. It could happen. It depends on the context, where you are, maybe some UI blocking thread. It depends. So, and there are other techniques to do so. So to start them, so for example, there is a way of starting a child so it becomes a nested workflow. And as you can see, again, with computation expressions, async computation expression, it's pretty simple to compose them. So you let child workflow to start, and then you sleep, and then you block on the child to get the result of that child workflow. Every composition of those results is done just with let exclamation mark keyword. It's really simple. Now we get to the point of mailbox processor. On the last meetup here, I talked about functional programming and the way of doing state management, the usage of shared state in between multiple threads, the concurrency in a functional way. So with immutability, you don't need any lock basically to access the same value or change the value from different threads. This is how a mailbox processor looks like. Like it's a class, built-in class. You don't need any other library for that. And you just start it, and inside there is an infinite loop which tries to receive a message and then do something with the message, and then it loops infinitely. This actually gives us a way of implementing shared state without locking anything in the memory. Yeah, that's how we call that printer agent. We post some message and another message and another message, and we can do it from a lot of threads or asynchronously, as many as you wish. Actually, you can create as many mailbox processors as you wish. You're not limited to threads. I have a demo for it. I hope I will be able to show it to you actually, because I cannot duplicate the screen. I can only extend it. So let's have a look. I will try. Okay. And yeah, okay. Let me start. Yeah, cool. So there is a simple application which makes counting task, and that's multiplication by 3. So 3 functions will start at the same time, and I have 2 functions to test locks and to test agent. What we don't see here yet is there is lock. No lock. Okay, how do I show it to you then? Okay, I have it here. So yeah, locked counter. So there is a class which implements the locking mechanism in an imperative way. So as usual, we have a lock object, we have some mutable elements, mutable variables, count and sum. There is an update state function which adds something to the sum and the message, basically the I, and count is count just +1, and then it sleeps randomly. Actually, it's a simple function which sleeps makes the thread sleep for 1 to 10 milliseconds, something like that. Yeah. So we have an add function, and I put stopwatch here. So we check how long would we wait until we get that lock object locked. Then we stop, and then we update the state. So let's try to run it. One more thing to check is, yeah, test locks. We test locks. So you can see here that client waited sometimes quite long, 255, 59 milliseconds, 233 milliseconds. So sometimes we need to wait until we get that object locked. We can rewrite it in a functional way with a mailbox processor. I will show you that one. So there is an update state which actually takes two arguments. One is a tuple of count and sum, the existing ones. So these are the old values, the previous ones. And there is a message which we add to the existing sum, and new count will be the old count +1. Then we sleep randomly, and then we return the value. So we don't just update anything anywhere, we just return. So it's a pure function, actually. Well, it's not entirely pure since it sleeps randomly, but overall it returns the same output all the time. There is an agent, mailbox processor, which we start and send the function, and as I showed you already, it's an infinite loop. We're receiving some message. We use the new state and we loop it to top, and the new state will be here when we receive a new message. And it's an infinite loop. Every time we get the previous state, and we can reuse it. So here I don't put any stopwatches because it doesn't make sense. Agent.post is immediate. It's async. You don't wait for anything anytime. So it doesn't make sense to put stopwatch here. And if we run this application with a functional approach, the problem is that we don't see any output, since it happens so quickly that the application exits even before it outputs anything to the console. So to see something, we can put let's say console read line, something like this. And we must ignore it because it returns some value, but we don't use it, and it shows us here that it's implicitly ignored. You shouldn't do that. So we just send it to ignore function. And if we run it now, we will see the output, but it's so quick, so immediate, so we don't need to wait for anything. And that state is actually shared. So when one function, everything is done in parallel, of course. So here we count from 1 to 10 and run 10 parallel asyncs, and each of them runs it 3 times. Everything is parallel. Everything is trying to access mailbox processor asynchronously, but none of the callers are waiting for anything. They just post a message and it's being processed, and that's it, and we're happy. So this is a bit about mailbox processing. Of course, it doesn't cover everything, but it's just an overview which allows you to. It's similar actually to Elixir or Erlang processes. There is such thing, and but it cannot be used across different machines or different applications. So it must be within one application. So let's get back to, oh, come on. No, not this one. I need another one. Yes, here. And yeah. I would like to tell you something about type providers. Type providers is some people blame it, so it's not the perfect thing, but I really see it as a powerful technique to access external data source. It allows you to use in your application some types, properties, and methods, and generate so-called provided types based on some external data source. You don't need to write JSONs to like an object representing a JSON to access some API. It will do it for you, and you even have an instant autocomplete. I have also a demo for it. Hope it will be visible. Again, it's pretty hard to show something like this, but let me try. Okay. Yeah, I have a simple application which contains only one program file, and it has one dependency on F# data. It's a Nugget package which contains HTML, CSV, XML, and JSON providers. Like this. Yeah. So what we do here is we have just some URL to GitHub issues, to actually F# language issues. And we create a type based on that URL, providing some root name for the generated namespace, but it doesn't matter now. What it does, it creates types for you to access that endpoint based on the JSONs it receives. So here you can see that I load the issues from GitHub from this URL, and then I can work with them and filter them and do whatever I want. So I even have IntelliSense here. This is assignee, body, comments, ID, and so on. All the fields of a real GitHub issue, but I haven't written any type for it, and I don't have GitHub library, GitHub API connection, anything. It's F# data, and it will generate any model based on the JSON it receives. So here, it just receives an issue, sees that field, and generates type for that. And you can work with it as they are in your assembly, but they are not. I mean, they are, but you cannot even see them. I tried to access the underlying type, and I couldn't. At least the writer cannot go to the definition, unfortunately. So yeah, and now if we run this application, we should see the top 10. Top 10 issues. This is the name. I don't filter them by type, so probably these are some pull requests or something like that. Yeah. So here, these are all statically typed. You can see it's a property of auto-generated JSON provider issue number is an integer. And it's super smart, actually. So it will generate options if it doesn't see some value. If it's null, it won't use nullable types. It will use options if needed. And also you can not only load something, but you can actually send. So you can send a post request. So let's say new issue is GitHub issues.issue, and we need to pass all arguments. I don't want to pass them all. Let's say I have a JSON value which I parse from something. Again, something. I won't send that request right now, but that's how that's possible. I would like just to show you that new issue dot JSON value dot request. Yeah, it's a function which expects a URL where to send that request, optional HTTP methods or end headers. by default it's post, but you can send any other method type. And of course it has async overloads, of course. Yeah, and for loading as well. Also, you can not just load, you can parse. So you can have just the JSON file in your project and parse it to generate those values on fly, on runtime, on CI. So yeah, that's how it works. It's quite powerful. There are already implemented, as I mentioned, HTML, CSV, XML, and you can write your own again. It's so it's doable. It used to be only full .NET framework. Now it's working in .NET Core. You can write your own type provider to anything what you want. Some people write them to some specific files. I don't know, some special schemas of some low level something. Yeah, so try. It's very easy to start, as you can see. Just provide the URL and it will generate everything from scratch. And if you want to go deeper, you go deeper. Now we're getting to Fable. Yeah, Fable, as I mentioned, it's probably the last thing I would like to tell you today. Fable, I just want to show you how powerful it is. So Fable, as I mentioned, it is a F# to JavaScript compiler, or better say transpiler. It generates a JavaScript which you can be proud of. That's at least what the authors of that library claim. But yeah, sometimes it's not that beautiful. It has a super simple, super easy JavaScript interoperation because, for example, Elm language, which compiles also to JavaScript, it's also purely functional, but it has huge problems with JavaScript interoperation. You must have Elm language, Elm package all the time, not only JavaScript, but with F#, with Fable, you can fall back to just dynamic typing. That's also possible. You can do that, no problem. If you are really sure that it will work, why not? It will allow you to go like really dynamic. And if you need to use any npm package, just import and use. That's it. It also supports most of the F# core language, core library, and .NET CLR like types. For example, it can properly transpile date time type to JavaScript date. So you work with it as a date time, but actually under the hood it's JavaScript date, and it works perfectly. And another great thing is that it has an online repo, which I would like to show you. And again, like this. Yes. Yeah, so this is the website, fable.io, and it has a REPL. I will not write any code, since it's hard to do, but I will show some samples which are here already. Let's start from something simple. And we can see a color fontaine. It's entirely written in F#. You can see it here. It uses actually even some overrides, as you can see, to string. That's also possible. And the HTML is just one canvas, basically, nothing else. CSS is empty, and the code generated looks kind of readable. If you really need to dig deep, you will find and understand it. Another great sample is, of course, a calculator. This is the code here. It uses Elmish, that architecture, and it's quite short, I would say, not that long. And whatever you want is here. Yeah, the screen is pretty small, but +3, yeah, that works. Of course, to-do MVC, of course, like learn, oh, come on, learn F#. This will be in our to-do list. and it's keeping the state in memory. You can see here the usage of button, strong, I don't know, span. This is a DSL over HTML, so that's how you write HTML in F#, because here, of course, it's just one div with an ID, and under the hood there is React, which generates all those elements. And yes, this is Elmish model view update. We will talk about it in details in our workshop, because here I don't want to cover that. It's yeah, it will need some time. So, but you can see that it's pretty neat. So you don't see any huge noise. Everything is pretty clear. And yeah, by the way, this is the update function, which just matches the message against some value and does and returns a new model depending on the result. You can go really far, because even Pac-Man could be written in Fable in F#, like real one. Entire JavaScript, yeah, of course. But yeah, you can do whatever you want. It's F#. So basically JavaScript becomes yet another runtime for this language, and you don't need anything else except the one language. Yeah. So basically it's all from my side, I think. I would like to give credit to Scott Voloshin. That's a great source of information on his website, F# for Fun and Profit. He also wrote a book, model-driven domain modeling made functional. If you didn't read the book from Eric Evans, Domain-Driven Design, you don't need that one. Just read this, and you will be fine. It has examples in F#, so you will learn F#, and you will know how to model your domain really in a clear manner. That's it. So I guess you have some questions. Yep. It's a general purpose language. I mean, it's you can do everything what C# can do, and even more with Fable. I think there is no C# to JavaScript compiler. So basically, you can use it everywhere. It's performant enough. Yeah, sometimes if you need really high performance, like I don't know, some micro or nanoseconds, I don't know, then yes, maybe it's not suitable that much. But overall, for business applications, web applications, backend applications, maybe even for desktop ones, that's easy. Let's imagine Visual Studio Code. It's written in Electron, in TypeScript, but the extension Ionide is written in F# transpiled to JavaScript and used as an extension. And again, it's desktop then. Everywhere, basically. Yeah, that's why I'm trying to say that I'm trying to make this language more popular, because it's not worse than any other language, but it has some benefits. It's great for domain-driven design. You can just really name things as they are. It's great for performance, for state management. It's used. It can be used as a like transpiled to JavaScript. Yeah, what I see a lot of benefits there, and that railway-oriented programming, it's not something unique. Of course, you can probably implement such things in other languages, but in F# it's kind of out of box, basically. Yeah, and error handling becomes much simpler, much clearer than in imperative way. Yep. Mainly in my in the project I'm working currently on, mainly we use it for integrations in Azure Functions because it's super suitable. It's functional language to write functions, Azure Functions. That's it. So all sorts of transformations are done super simple, and you get one thing and you return another thing. That's a transformation which can be really easily done in F#. From my point of view, it's much easier than in C#. And these are the .NET languages are like natively supported by the clouds, especially by Azure. So I choose F# for that, and it works super well for us. We're considering to rewrite front end in Fable. Actually, this will be like a huge project, but I believe we will do that. Yeah. Yep. Sorry, once again, please. The great thing about F# again, it's that it's .NET. So you don't need to learn the ecosystem, the infrastructure. So it's the same thing. All the APIs are the same from .NET framework. So that makes it a bit simpler. You can actually work, as I mentioned, you can work in an imperative way, in an object-oriented way in F#. So what you can do is start step by step. So firstly, you switch to another syntax. To learn a syntax, I don't know, that doesn't take long, really. So you continue doing things in the way you used to, but you in another syntax. Then you step by step start applying new techniques, more functional techniques. You make use of that everything is an expression. That's really, I miss that when I still need to work with C#, unfortunately, as there is some legacy code base in C#, and I really miss that everything is an expression. I cannot use if statement as an expression, but in F#, if is an expression, so you can just combine, wrap it in, I don't know, into parentheses and pass as a function. That's it. Yeah. So step by step. I cannot say any time frame. I cannot think up, but it depends. But I strongly believe that there is nothing. It's not rocket science. It's possible, and some of us are working with rocket science, right? So if we can do that, why cannot we utilize F#? It depends. But what is good is that it's still the same ecosystem. To switch an ecosystem from, I don't know, to Haskell, that would be painful, like really. But since it's the same .NET as you are mentioning C#, yeah, it would be pretty straightforward at least. Yep. Once again, please. Yeah, there is SQL type provider, so you can even do it like on run, like while developing. It can connect to the database, see the schema, and you will have the autocomplete. It will be kind of DB first, auto-generated, but it's much better than with C# entity framework and DB first. But I would recommend to use something simpler like Depper, like some small CRM, like write real SQL code by your own, because sometimes all those auto-generators work unpredictably. Even entity framework can output such strange SQL code and compute something in memory. I don't like those ORMs. But yeah, there is SQL type provider, and there is query computation expression, which also allows pretty much the same thing. Yeah, so it's possible, it's doable, it's in the core of the language. You don't need anything special for that, actually. And you can fall back to edo.net. Write SQL connection directly and pass commands and parameters, everything. Yeah. That's it. No more questions? Okay. Well, I showed you the compilation. And once it's compiled, the cold start, like it depends on your application what it does, but that's the main difference between compilable and interpretable languages, let's say. So this will be, yeah, you spend some time in compilation, but you also spend it in C# or in any other language of such kind. So I don't see it's a problem. Compilation time is not execution time. Scala? I don't have much experience, probably any experience with Scala, but with F#, it's pretty much the same as with C#. You load only what you need, and it doesn't load that much, especially with .NET Core. And later on, there will be another way of compiling things, and it will be even faster as far as I know. But yeah, I believe it's faster than Scala. It's just my kind of feeling. That's it. PowerShell, don't use PowerShell, use F#. Yes, if we want to compare some JavaScript to other languages, that's another huge topic, but I don't feel comfortable when a language can allows you to pass completely wrong types and consider them as they are like something else. Like dynamic typing, it's so wild from my point of view. Yes, it brings some speed, but again, which speed? It doesn't have multi-threading, let's say. It's just one JavaScript, one thread, or how it's called. Everything is on callbacks. I don't know. It's an ongoing discussion. Dynamic typing versus static typing. Yeah, compilable versus interpretable languages. I prefer this way. Yeah, I can spend something on compilation. I mean, I'm fine. The build server does it for me, and then it loads and pretty quickly. There was a comparison actually about cold starts of Azure functions, and yes, probably JavaScript starts faster, but it's much less safer than F# or any other statically typed language. In F#, you don't need to test many things. Many things are just checked on the compilation time. So the types, again, you won't even need, you just set invalid state unrepresentable. That's how they say it, and you don't need to test that later on. Less unit tests, less work from your side, so less time spent. It's always pros and cons. Yeah. Yeah. It's the same thing. You can choose when you want to have it as a struct, keep it in stack. You can do that. You just put an attribute or a special keyword struct, that's possible, or like primitive values, primitive types, like I don't know, integers are also kept. It's the same as in .NET. Even the record types, as I mentioned, they are reference types. But they are just compared by value. But anyway, they are stored in the heap. Yeah, of course. So basically, everything by default is in C# by default. If you create a class, or you can actually create a class in F#. It's you just don't use class keyword. You say type, but it becomes a class, and you can actually pass it to C#. They're quite well interoperable, so you can have in one solution you can have projects in C# and in F#, and one will consume another. And yeah, just make sure the interfaces, the contracts are suitable, because C# doesn't know anything about discriminated unions. That's kind of annoying, but a part of that, interfaces, implementation, heap, yeah, reference types and heap, yeah. Okay, so now I think we can announce the winner. We should have competition results by this time. Let's check. Okay. Should have a. Yeah, I don't have a winner. Who is Hape? Right, cool. So it's the closest value. Yeah. It's always hard to count the lines, but others are not even close to that. So you anyway, you're a winner. Of course, it changes all the time. It's open source, and yeah. Anyway, congratulations. I guess the Vistaprint representatives will contact you and give you the prize, the ticket. Great. Thanks for attending. And yes, actual number is 162,000 lines, plus minus, I don't know, hundreds, because it's evolving, it's always changing. Pull requests are merged, I don't know, every day. So you can imagine it's 162,000. Yeah. So then, thank you very much, Dekui, and welcome to my workshop on the 2nd of November. Feel free to sign up. I will tell more about full stack development in F#. We will cover Fable, Saturn, other ways of combining them and sharing the code between backend and frontend. You won't need to write models on both sides. It's just one model, and you won't even need to use any HTTP or fetch function or object directly. There are greater techniques in F# implemented already, and it's super simple, super straightforward to have everything entirely in F#. Thank you again.